Hi. For the last few years of my life, I was completely obsessed with chasing the classic tech startup dream. Specifically trying to build B2B software, sacrificing every single weekend only to collect no after no until the sterile corporate grind completely burned me out. It felt like I was losing touch with why I even started coding in the first place, so I took a step back. I wanted to build something with an actual soul again. That's when a close friend and I decided to team up to build our dream project. A story-driven, pixel art, magic school RPG where players can actually get lost in the world together. Going from dry business databases to complex magic systems and figuring out multiplayer netcode is definitely a massive shift. It's a huge challenge and we have a really long journey ahead of us. But for the first time in years, I'm actually excited to sit down at my desk and write code every single day. So, I'd love for you to join us on this journey. Today, we are diving straight in by building a multiplayer sync chess system and dealing with all the headaches that come with it. Alright, let's see what we are working with here. Let's jump straight into the game. We've got our prototype character ready to go, and now we are going to add a simple white square to serve as our placeholder chest. Let's drop that into the scene. Next, we'll throw an interactable component on it, which is what our new chest system is going to attach to and hook into. Perfect. Now, because this is a multiplayer game, things aren't exactly going to be trivial. So, let's take a step back from the keyboard for a second and sketch out how this logic is actually going to work. Alright, as you can see from this beautifully, and I mean expertly crafted graphic, our entire multiplayer system is split into three main parts: the client, the server, and the shared layer, which I personally like to call the bridge. When a player walks up and tries to interact with the chest, the client sends an open request to the bridge. This kicks off a check on the server side portion of the bridge to answer one simple question: can this chest actually be opened? It checks things like distance, but most importantly, it makes sure another player hasn't already beaten you to it. If the server-side bridge gives us the green light, it fires a response back to that specific target client, basically saying, yep, you're good, open up the UI. At the exact same time, the server-only code catches an event call. This is where the server handles the heavy lifting, like generating the specific loot if it hasn't been generated already, keeping everything secure and cheat-proof. And here is the beautiful part about this setup. Let's say two clients try to open the exact same chest at the absolutely same microsecond. Because our bridge is completely server authoritative here, the server processes the first request, flips this open flag to true, and immediately rejects the second client's request. Alright, let's dive into the code and actually implement the logic we just laid out. We're going to start by building the system right on the bridge. First up, we need to define a sync var. Basically a variable that stays perfectly synced across the entire lobby, and we'll call it isOpen. Next, I'm setting up two events. One to trigger our server-only logic, and another to signal the client-only side. Oh, and let me just turn off Copilot real quick. Wait, seriously? Is there only a snooze function now? Oh well, yeah. Anyway, let's write the server-side code for the bridge. This is going to handle checking whether the chest is available to be opened, and if everything checks out, it will fire off those corresponding events. Now we need to tackle the client-only logic, which means handling the actual input, like when a player presses E to interact, and setting up the functions that open the UI. First, the client does a quick local check to see if the chest isn't already open. If everything looks good on our end, we fire off that request to the bridge system we just built. Now, for the UI itself, we need to add a listener to that event we set up earlier. That way, the moment the server-side bridge gives us the official permission, the client hears it and actually pops the UI up on the screen. Alright, let's finish this basic structure up by writing the script that runs solely on the server, which listens to the server-side event of the bridge. Here we are going to generate loot, etc. after a player opens the chest. Before I move on to building the actual UI, handling the item transmission and testing everything out, I think I'm going to take a quick break. I'll probably go for a little night drive and walk to clear my mind. These little side quests, as I like to call them, are a lifesaver. They really help reset my focus and keep me productive in the long run. Follow me! Honestly, just sitting on a random bench out here in the middle of nowhere is surprisingly grounding. You've got the sounds of nature in the background and absolutely no distractions. It just lets your brain reset. But alright, enough staring into the dark. I think the plan for the next step is finally locked in. Let's dive into actually building the UI. Since we are using Unity's UI Toolkit, it feels a lot like you're working with HTML and CSS. Except we get this really sleek graphical editor to handle the layout. So now, instead of just opening the placeholder window, we can feed our script the brand new layout we designed and spawn a window with the actual content. Next up, we need to define our item element and hook up the chest UI logic so it can actually display and list all the stored items. On the networking side, I'm adding a sync dictionary to the chest, so all of those items are properly saved and synced across the network and for every player. And also, I'm setting up a few interfaces to make accessing and managing those stored items super straightforward. Right here, I'm writing the code to instantiate each item entry directly into the chest UI. Once that's set up, it's time to handle the RPCs, or remote procedure calls, which are basically how the client and server tell each other to start specific functions. In this case, the client sends a request to the server to open the chest. The server checks if everything is valid, initializes the items, and sends a confirmation back to the client. As soon as we get that OK, the client UI officially pops open. Now let's slap these scripts onto our objects, wire up the UI elements and see how it looks in action. Oh, well, that's definitely not working. Let's see what's going on. Oh, I think I found it. Turns out the interactable script had some essential indirection code completely commented out. Oops. Anyway, with that fixed, the UI actually opens now, but there still aren't any items showing up. Turns out I forgot the single most important line of code, actually adding the item entry to the chest UI container. That's a classic one. Let's fix that real quick. Perfect. Now it's properly displaying the 3 potions the server was told to put in the chest. If we right click and hit collect, voila! We now have 4 potions in our inventory, up from 3. We officially picked up potion from the chest. Now, all that's left for this pass is making sure the chest UI dynamically updates the moment its contents change. Once that's hooked up, we'll have a really solid foundation for the chest system to build on later. And now for the moment of truth. And perfect! The UI updates instantly and the potion transfers right into our inventory. To make it even clearer, I went ahead and tweaked the starting state so our inventory begins completely empty. Look at that! Awesome! Everything is syncing, updating and working exactly as intended. That's going to do it for today's devlog. We got the UI hooked up, the RPCs sorted out, and inventory syncing working smoothly. If you're enjoying the project, make sure to leave a like and subscribe so you don't miss the next update. Let me know in the comments what you want to see next. Until next time!